young, I didn't know very much. And I think one of the things that I prayed for, I didn't have a very good idea of God or anything, but it's like, I think here in this part of the world, you just pray for stuff, right? I mean, well, okay, if you're a hardcore atheist and you never prayed for stuff, that's fine for you. But I was young and I prayed. And I prayed, people pray for many things, but I prayed to be a genius. Of all the things to pray for, it's something that I regret now. It's like, like I want to go back in time. It's like, what are you thinking? It's pray to be a genius and to be smart and intelligent and know stuff. Well, it turned out that as time went on, I now know stuff. I now know stuff that other people do not know. And software is something that is very close to my heart because I've been programming since I was like 10 years old. Like a lot of you here, have been programming since, since they still had their milk teeth. And if you look at how things are going, it is software is so much a part of our lives. Software gives us has contributed so much to the convenience of our lives, but software has also taken so much from us. Software and its errors and its crashes and its confusings and all of that have taken a big bite out of our lives. And so I want to do something about it. I feel like that's my calling, my vocation. And it turns out that there are people who have been like that as well. I think, a man whom I call my teacher, Edgar Dijkstra, one of the winners of the Turing Award, have spoken on this, about this, right? The software crisis is actually not a name that he made up, but it was actually a conference in the 80s, right? The software crisis is something that, like the bugs and everything, that's been known for a very long time. And it's like, what do we do about writing software that does not make our lives miserable? And we're going to talk about this at one point. We're going to talk about null references, which is a very big error that has, if any one of you has used Java, you have come across a null pointer exception. So Edgar Dijkstra died. Edgar Dijkstra died in 2002, I believe. And I don't think anyone has taken his place. He was a prophet of software, right? In the sense that he had this vision of how things are going to go, and it's quite bleak. If you look at his writings, right, he writes in a very bleak tone. And now that he's gone, I feel like someone should take his place. I think that if you look at the blogs, look at the entire universe of intellectuals in computer science, not enough is being said about writing software correctly. Yeah. And in one of his famous pieces of writing, he said that maybe you should scale down the ambition of the software that you want to write, in order, to be able to produce software that is more correct, right? Now that's not going to go well for business for the business purposes, right? It's like you got to go out, you got to chase the market, you got to grab the market share before anyone else does. And if it means buggy software, so be it, right? And you could also say that, well, yes, from what we have seen, people are willing to tolerate buggy software, software that crashes. An app that crashes on your mobile, well, you just relaunch it, try it again. And sometimes it works, right? So, okay, without further ado, let's get into the talk. It's 8 o'clock. We are quite early, but this is a 25-minute talk. It is quite dense, okay? So I'm going to divide it into 2 parts. And then after the first half, we'll do a mini Q&A, and then the same for the second half. Selamat malam, berapa, minggu depan udah masuk bulan puasa, and then setelah itu insyaAllah Lebaran, and satu tradisi Lebaran adalah kita minta maaf, ya. So, minta maaf. Sekitar 9 tahun yang lalu, seorang ahli computer science minta maaf. Bukan Dijkstra. 9 tahun yang lalu. Dia mengakui berbuat dosa yang besar banget. Berapa ongkos dosa itu? Dia mengakui dosa itu merugikan $1 miliar, bersamaan 14 triliun rupiah. Apakah kesilapannya? Siapakah pendosa itu? Ladies and gentlemen, I present to you Tony Hoare. By way of introduction, Tony Hoare was given the Turing Award in 2010. Now, as you know, the Turing Award is the biggest award in computer science. He didn't win the award because he apologized for his mistake. Yeah, he won the award because of his many contributions to computer science. And quicksort is one of them. Many people may not know Tony Hoare, but many programmers know quicksort. So back to the question, what was his billion-dollar mistake? And the answer is the invention of the null reference. This is Tony Hoare's, this is the first slide of a talk that he gave in 2009. So, to be precise, a null reference means that a variable need not refer to an actual piece of data. It could refer to null, as you can see on the slide. What does that mean in the real world? So since we are at GoCheck, let's tell a GoCheck story. I don't work at GoCheck, so some of the things I'm going to say here may or may not be true. We're going to use the GoCheck app as an example. We launched the app to search for a GoCheck. Yeah, sorry, I should have timed out. Can you just fix this here? But it's 5 p.m. and everyone is looking for a GoCheck too. So it turns out no GoCheck responds to our request. They're all busy serving other customers. In the earliest versions of the app, if no GoCheck can be found, guess what happens? The app crashes. So a GoCheck developer troubleshoots this crash, and this is what he found. The Android app was expecting a non-null GoCheck object, and so when it was given null, it crashed with a Java NullPointerException. So this is the problem with null references. This is Tony Hoare's billion-dollar mistake. Every function that's supposed to return an object, it can always return null instead. Whether it is a deliberate decision on the part of the programmer or an oversight. Here's a situation which you do not want to happen to you or your family. With the GoCheck app, it crashes, you just restart. A Java-powered machine in the hospital has some code that didn't handle a null. Whoops. What could that mean for the patient? Imagine the consequences of that null pointer exception. So, what do? The solution is obvious, you might think. The solution is to check for nulls. Check for nulls and write logic to handle them. Like this, right? If object equals null, do something. Now, it turns out that this solution itself has a problem. And it is this, over-checking for nulls. We have a problem, null dereference. We have a solution to the problem, check for nulls. And that solution, in turn, gives a problem, which is over-checking for nulls. So what is the cost of that? The problem of over-checking for nulls is the essence of the fourth highest voted Stack Overflow question for, in the Java category. If you write code that checks for nulls everywhere, even in places where it's not necessary, one, your code will suffer in performance. Okay? And what's worse, you have all these extra lines of code that creates extra maintenance cost. Is there a better solution than checking for nulls everywhere? And there is. And in Java, we have non-null and nullable Java annotations. Can I just have a show of hands, people who have like just some Java experience, any Java experience? You have written any kind of Java at all? 1, 2, 3, 4, like roughly half, roughly half of the room, right? So you can all read this. Find GO-JEK is a method that takes a location as input and returns a GO-JEK object. Now, because you have this nullable, at the very beginning of the method declaration, it means that the return object, the GO-JEK object that is supposed to be returned, may be null. The caller of this method, find GO-JEK, is responsible for checking that the returned object is not null before accessing it. Okay? Now, that's not the only thing the caller of find GO-JEK is responsible for. It's also responsible for ensuring that the location passed to find GO-JEK is not null. Because that non-null annotation says that this method absolutely expects the location passed to it to not be null. Okay? That's what the blue annotation is saying. Everyone following so far? And I have a problem with my slides.
That's not working.
Yeah. So with this example, I hope you're getting a better intuition of what exactly is wrong with null references. It's not that null references are evil in and of themselves. It is that null references cannot be distinguished. They cannot be separated from references that are never null. So these annotations, non-null and nullable, give us back that distinction. See what is going on? So it means that we no longer check for nulls. when we don't need to, right? So the define GO-JEK method says that, look, I'm not going to check for null for the location. So it is the caller's responsibility. Whoever is calling find GO-JEK had better not give me a null object. It also means that we no longer forget to check for null when we should do so. Yeah? So because if we don't check for null, and we should check for null, then we risk having a null pointer exception blowing up in the user's face. There are languages that kept this separation right from the beginning.
It's not changing the slide.
Oh, it's not changing the slides?
Yeah. Do you want to use the pointer instead?
There is something wrong with the, what happened here? You know, I tested it at home and it worked. I don't know what is going on here. See, I need Wi-Fi. I need Wi-Fi. So, you know, look, I have this mini Wi-Fi thing, you know, in my bag, and so what I'm going to do is, you know, I mean, it should work here. Okay.
Okay. Can you try
Yeah.
to change the slide?
So it's fine. I think it should work. Yeah. So as I said, null references is not. It's not evil. It's not bad in and of that sense, but it's that you've got to keep things separate, right? What are references that can never be null, and what are references that may be null? So, as I was saying, there are languages that kept this separation right from the day the language was born. In fact, these languages, not Java, these non-Java languages, it is impossible to mix nullable references and non-null references. Haskell is one of those languages, and here's what the type signature for find GO-JEK looks like when written in Haskell. In Haskell, data types are not null by default. So when types are nullable, we explicitly state they are nullable by modifying their types. We're actually extending their types with maybe. So we type them as nullable. Now, for those who know Haskell, you know that this signature is not quite right because find GO-JEK is an effectful function, so the return type has to be in IO. But let's pretend that this is a Haskell dialect, yeah, that allows IO effects everywhere, just like Java does. Okay, so let's pause for a minute. We have just covered the billion-dollar mistake of null references. We have seen that it's not null references, but it's the fact that they are just all, you know, thrown into one big pot. And finally, we've seen the correct approach. You know, you got to separate those two. Don't just, you know, dump all of them into one big pot of types. And this is the first half of the talk. Any questions so far? Everything good? Any questions about Haskell? I've thrown some Haskell at you. I recognize that, you know, not everyone has played a lot with Haskell. Yes.
So if we have to separate two state, what's the initial state of nullable and not null kind? The initial state.
Okay. State. So Haskell programs declaratively. It's not really imperative. So you don't actually have an initial state. This is something else that, you know, it helps to distinguish in computer science, right? The word variable means a lot of things, and sometimes they mean things that should be kept separate. Just like, you know, this is it's fractal. This is a problem that keeps repeating. So, by a variable in Java-like languages or C++ languages, a variable models a piece of memory, a memory cell. Okay. In Haskell and some other languages, there is no such model. It's just a name. So we don't say, so with Java and C++ languages, we say that we are assigning a value to a variable, which means that we are sort of like, you know, modeling it by, you know, we put something into a memory store. In Haskell, yeah, we don't say that. We don't say we are assigning or we're modifying memory store. We are just labeling, or we use a technical jargon, binding a variable to a value. So what happens, what that means is that in Haskell, there are no unbound values, right? This is a problem that you will find in C, for instance, right? That portable assembly language, you can define a variable, right? You can declare a variable, and the variable refers to, you know, a piece of memory, and it's uninitialized. So if you use that variable, right, without putting anything inside, you could get anything out of it. I hope that answers your question. Okay, good. All right. Any more? We have time. We have, it's 8:22, so we need to, the second half takes only about, you know, another 12 minutes. So if you have questions about Haskell, please ask them now. Okay, let's move on. So we've just talked about how Java null annotations and Haskell maybe monad are similar in that they solve the problem of null references. So let's talk about the differences. In Java, annotations are comments. The Java compiler actually ignores those comments. Maybe you can press the shift key a little bit, you know, every now and then, so that the screensaver doesn't kick in. I forgot to disable it. Yeah, the annotations are not visible at all to the Java compiler. In the Haskell case, maybe is a type constructor defined in the standard library. This gives us the best of possible worlds because it means that there is no specific magic in the compiler that handles maybe. So if you don't want maybe, you want to call it something else, you can actually do that. You know, you can actually not use maybe by, you know, just specifying an option to the compiler to not load the standard library. So in Java, annotations are ignored by the compiler. So how do they actually work? You need third-party tools. Some IDEs, like JetBrains, uses them. Some standalone checking tools, called static analyzers, also read those annotations. And you have to install those third-party tools, and you must run them in addition to the Java compiler to get the safety you want. With Haskell, the compiler checks types when it compiles. There is no additional step. If you forget to check for nothing, which is what null is called in Haskell, then what you get is a compile time error. In Java, because these annotations are not standardized, the third-party tools I mentioned earlier, implements them in proprietary ways. They don't even use the same syntax. This is a 715-point question about Java on Stack Overflow. It asks exactly this question. Which null annotation should I use? And if you look carefully, there are at least 3 syntaxes shown for not null. So there's not null, and then there is non-null with 2 capital N's, and then there is non-null with only 1 capital N. And these are, these are some of the different links to different tools that do these, that process these Java annotations. And it turns out that all of them have different semantics when it comes to edge cases. Now, in Haskell, maybe is actually a fairly simple type declaration. Haskell programmers know it by heart. Data may be A equals nothing, pipe, nothing, or just A. The biggest benefit of the maybe monad is the meaning of a type declaration is standardized in the language, in the Haskell language definition. But really, the biggest benefit of the maybe monad is that you can check and you can propagate nulls almost for free. And we're going to see an example of this free checking and propagation of nulls very soon. So let's move to SQL and 3-valued logic. This is the second part of the talk proper. Here's a common SQL newbie mistake. We have a database of all tukang GO-JEK. Waktu pendaftaran, ya tidak semuanya membawa kartu keluarga mereka. We want a list of names and of IDs of those who didn't fill in their nombor KK. So for those who know SQL, what does this select statement return? Nothing. Good. Yes. No rows. 0 rows. There are people who did not fill in their nombor KK in the database. But this select statement returns nothing. Why? Why? You cannot write field equals null as a condition for the where clause. Well, you can. The SQL, SQL will not throw an error. It is legal syntax, right? But it's not what you think it means. You have to write field is null. Is that correct? Yeah. This is one of these sharp edges with SQL. Why is the clause x equal null wrong? The reason is that it will always return null. The select statement only returns rows where the where clause returns true. Not false, not null. Null is also sometimes known as, also called unknown when it is a Boolean value. So why does x equal null always return null? Because the equality predicate, SQL uses this single equal sign, because this equality predicate implements maybe monad semantics. And this is what the type of the equality predicate looks like in Haskell. Takes 2 values and return a bool. Now, earlier I said about how you can get null checking and propagation. Null checking and null propagation in the maybe monad almost for free. Here's what I mean. Whenever you have a function of type A to B to C, you can get a function of type maybe A to maybe B, nullable A to null, a function of type A to B to C is a function of non-null A to non-null B to non-null C. You can get a function of type nullable A to nullable B to nullable C almost for free. you have to apply an effect combinator on it. So here I call the, that combinator, that higher order function extended. Now, why is it called extended? Because it extends the functionality of the equality predicate, right? It has all of the old behavior whenever you gave it, a non-null value. But whenever it gets a null in either of its inputs, it will automatically return null as the output. That's null checking and propagation almost for free. So what that means is x equals null always yields null. A equals null is null. Null equals A is also null. Null equals null is obviously null. Okay? So the big idea here is this, you have your non-null function, and then you can get a nullable function almost for free. That's the big idea here. So here SQL null behaves like Haskell's nothing, in the maybe monad. Okay, let's invite the SQL programmers in the audience again. What does this select statement return? Press the shift key. Oh, okay, good. Thank you. Any takers? So basically, we are trying, this pivots on the value of true or null in SQL. What do you think it returns? A show of hands, people who have programmed in SQL before. Some, yeah. So maybe this is a case that you have not seen. True or null. What does it return? Okay, all right, never mind. It's late in the night. Now, according to what we've said, OR is a binary operator on Booleans. When we extend it to work on three-valued logic, the type becomes, nullable bool to nullable bool to nullable bool. Now, according to what we have just said, whenever one of the inputs is null, the output is also null. So true or null should be null. And so the true branch will not be taken. The else branch, we go down the else branch and it says to return false. So we expect this select statement to return false. Yes? But if you enter this exact statement in MySQL or in SQLfiddle.com, you will get true. And that's because the Boolean expression true or null returns true, not null, as we expect. What is going on? Here's the table for SQL three-valued logic for Booleans. Now, unknown here is a synonym for null for some variations of SQL. SQL syntax, by the way, if those who are sort of polyglot SQL programmers, those who have to work with more than one SQL database, and like you have to work with a MySQL, PostgreSQL, and Oracle and SQL Server, you realize that SQL syntax is very, very unstandardized. So much for the digression. Notice that true or null is true. Null or true is also true. False and null is false. And null and false is also false. This is like the so-called short-circuiting semantics for Booleans. Given an expression true or x, whatever x is, that expression evaluates to true, right? True or x, whatever x is, true or x is true. And similarly, false and x, whatever x is false. So So here, null is no longer Haskell's nothing. What it has become is really a free variable, a Boolean valued free variable, right? A variable that varies on all Booleans. So, true or false is true, true or true is true. So if true or x, and where x can be either true or false, it has to be true, right? So, but this is, we've got two, but this is null and this is null, and null behaves, these two nulls behave very differently, but they are called by the same word. Lots of people find SQL's free valued logic confusing. And as we have seen, it is confusing. Now we know why. Because its semantics are not consistent. There's one semantics for Boolean nulls based on free variables. There's another semantics that's based on the maybe monad for everything else. And that's the second part of my talk. Questions?
Questions?
Yeah, so there's a question here on Haskell. Is the maybe monad something like Swift optional or Scala optional, something like that, with a question mark?
Yes, it is something like that. The reason why I why I don't want to say it is exactly like that is because in Scala, you still, Scala tries, is this problem with backward compatibility, right? Now that we know that, look, all right, like Tony Hoare, it's like, oh, we made $1 billion mistake. Why don't we just go back and fix things? Why don't we change the definition of Java? Well, if we change the definition of Java, guess what happens, right? You got pretty much half of the world mad at you because your code no longer runs. So Scala, wants to, it tries to have its cake and eat it too, which is that it wants to, show you how the right way to program, but it's also got to spot all the old code. So in Scala, as I understand it, you can still do null references, which sort of like defeats the purpose of having of this strict separation, right? So, but yes, the spirit is the same. Swift optional, Scala option type, and even Java 8, which has introduced this optional type as well. Anyone kept up with Java 8, right? It tries to go towards there, but it's got all of that baggage, and so I didn't go into Java 8 tonight because it's a very big story there, and it's not a nice clean story as we have seen here, right? And if you look at search on the web about Java 8 optional, there's a lot of confusion. Half of the people say, oh, this is wonderful. The other half will say, no, avoid it, because of all the reasons that you already know.
Okay, thank you.
Nice question. Thank you.
Hello. Yeah. It was an interesting. Thank you.
Thank you.
So you talked about type constructors in Haskell, right?
Mm-hmm.
So I wanted to know what are those and what is their significance?
Okay. So a type constructor basically takes a type and gives you back another type. It is like a type function. But we don't want to say function because it introduces things like, you see, a function has this mathematical sense where, we talk about the domain of a function and the codomain for a function. Now, when it comes to types, it tends to get very, very messy. So we just want to say that, instead of saying a type function, that maybe it's a type function, we say it's a type constructor, which is that it takes a type and gives you back another type out, and leave it as that.
So we basically consider types as first-class citizens.
Types are first-class citizens. it depends on what you mean by first class. No, types are not first class in the way functions are first class. I think if you, I'll just say that, you know, the path that you're going on, you know, when you talk about like making types programmable, that falls under the rubric of dependent types, right? So where we want to be able to program with types the way we program with functions. But types are, Haskell lets you manipulate types in very flexible ways. That's true, yeah.
Okay, another question? Okay. Yes, a couple of questions here.
Yeah, thanks for a very interesting talk.
Very welcome.
This is regarding, so the Haskell, you were talking about the maybe monad, right?
Mm-hmm.
Now the thing is, maybe monad does not solve your null pointer problem,
Okay.
null reference problem.
Mm-hmm.
Now you have something that may return A or
Mhm.
may return null.
Mm-hmm.
Correct. You still have to check for that condition,
Mm-hmm.
right?
True.
So what's the benefit? Where does the benefit lie?
Well, if you do not check, you know, if you have a function that say returns a Boolean, and you have been using that function all along, you know, in a different part of the code, and because it returns a Boolean, you know that you don't have to check for that Boolean, check whether or not it's null, right? So you don't actually check for it, right, in that part of the code that calls that function. Okay, but now suppose, you know, we have there's a refactoring exercise in the code base, so that old function that used to return, that used to guarantee that is not null, it is now maybe bool, right? It is now maybe bool. So what happens is that when you try to compile the code that calls this revised function, you will get a compile time error. So the compiler tells you, look, right? You're expecting a bool from a maybe bool. You can't always get a bool from a maybe bool because a maybe bool may be nothing. I mean, that's what maybe bool means. It could be nothing. So you have to handle the case now, right? And it is a compile time check. It is not a runtime, you know, thing that blows up in your user space.
Okay, that's valid. Now the question I have is that a maybe bool is also a type.
Yes, it is a type. That's correct.
So I can just have a variable there which is a maybe bool.
Yes.
So one way of refactoring would be I just have like maybe bool, maybe just convert all bools to maybe bools. I'm just saying it's a bad way of refactoring. I agree. But
If you want to, yes, if
Yeah.
you want to.
So
And in fact, you can do that. You don't, and that refactoring can be very, very minimal because there are ways, you know, using what I said as effect combinators. You can always take a function and then convert all of its parameters and its result type to maybe. So you don't actually have to go into each of the code. You can just sort of, you know, and this is where the Haskell, which is notorious for all the symbols, right, you know, come in, because these symbols actually let you just, you know, just put in 2 or 3 characters and that's it. You have just refactored it.
So I guess
Mhm.
again, what I'm trying to say is
Yes,
this whole concept, the maybe monad,
yes.
right, can be misused and is not actually the solution, right? But it
Mhm.
allows you to know. So suppose the function used to only return bool
Mhm.
and now returns maybe bool.
Mhm.
It just tells you, okay, you need to change all of this code, which is good.
Yeah, the downstream code,
Yeah.
the code that, you know, receives the result of the function. Yeah. Yes.
Okay, another question? Nobody asking what is all of this.
You're going to ask.
Okay, another question? Or it gets really confusing. Oh,
Well,
quickly.
thank you very much. Yeah, thank you very much. Yeah, yeah, it's 8:45. Great, we're doing great on time.
So, okay, thank you, Abdullah. Give him a big round of applause.
Thank you. Thank you.